Hey everyone, today we're going to do arcs and chords. So we learned already that a chord is the segment, any segment that goes across from one side of the circle to another. So today we're going to learn about how we can tell that two chords are congruent, and we're going to look at these 2 points here. Two chords are congruent if and only if their corresponding arcs are congruent. So AB is congruent to chord CD. If their corresponding arcs are congruent. So if they give you the measure of AB is congruent to the measure of CD, then you know the chords are also congruent. The other way we know that chords are congruent is if they are equidistant from the center. So if you know that from the center these two lines are congruent, then you know the chords are also congruent. So AB is congruent to CD. If we know that EF is congruent to EG. Another thing to note about chords is if a diameter or radius is perpendicular to a chord, then it bisects the chord and its corresponding arc. So an example of that is if EF, if this is showing this is perpendicular, so if EF is perpendicular to AB, if EF is perpendicular to the chord AB, then you know that AF equals FB because they got bisected. And you also know that their arcs, the measure of AH also equals the measure of HB. Because the arcs got bisected. As well. So the arcs get bisected and the chord gets bisected if a radius or a diameter is perpendicular to the chord. Let's look at some examples here. The first thing we notice is they're flat out telling us those two chords are congruent. If we know the chords are congruent, then we know their corresponding arcs are congruent. So we can set this up as equal to each other and solve for x. In this case, number 2, it's telling us that the arcs are congruent, so let's find out what x is. Oh, I'm sorry, they want to know what xy is. So they want to know what the measure of xy is. So we know that these chords are congruent since their arcs are congruent. So we are going to get 5x equals 35. X equals 7. And since they want to know the length of xy, we really could choose either one of them because they're congruent, but let's stick to what they gave us for xy. That's going to be 4 plus 1, and we're going to insert our x there, which is a 7. So that'll be 28 plus 1. So the measure of xy equals 29. In this case, they want us to find the measure of MP, so that's going to be in degrees. They told us that the measure of these are that, and we know that they are equal. We know that we can set these up as equal, and let me show you why. I'm going to set them up as equal. But the reason we know they're equal is because right here it's showing that they're equidistant from the center. In our notes up here, we learned that's one of the ways we know the chords and the arcs are congruent is if the chords are equidistant from the center. So with those set up as equal, we can solve for x, and then we can solve for MP. So let's solve for x. We're going to have 4x is equal to 76. X is equal to 19. And that's great. Once we know that x is equal to 19, we can go ahead and find the measure of one of these arcs. So let's put it in here. That gives us, hold on, got to get in my calculator. All right, we've got 128 degrees. So if we know that the measure of this is 128 degrees and we know this one equals it, it's also 128 degrees, then we can take 360 minus the 128 minus another 128, and we will get what's left over here. So MP equals 104 degrees. So 104. The three arcs together will equal 360. All right, this is a little bit of a new skill here, so pay attention to this. It says find the length of CF if the radius of the circle is 10. So the radius of the circle is 10, which they didn't actually give us a radius, but I'm going to draw it here because this is the one we're going to need. We're going to form a right triangle, okay? We're going to find this leg of the right triangle. If we know the radius is 10, the radius of the circle is 10, and they're wanting to know this length, so we don't know that length. And we do know that the distance from here is 6. So let me read that to you again. Find the length of CF. If you know the radius of the circle is 10, so I went ahead and drew a radius. And you know the distance from the center to the chord in question is 6. So now we have a right triangle we just created. It's got 10. We're trying to find that portion of C, which is CF, and we'll just use Pythagorean theorem for that. So we'll have x squared equals 100 minus 36. X squared equals, let's see where I did my math, 64. So x equals 8, and so we found the measure of CF equals 8. Okay, and we're going to draw another right triangle in the next one as well. So let's look at this one. We're going to go ahead and draw our own circle now. Okay, this one says there's a chord that's 24 inches, or 24 centimeters. So the chord is 24 centimeters long and is 15 from the center. So again, 15 from the center. Find the length of the radius. Well, we don't know the radius now. I do know it's located here. So there's our triangle. Let's make it a little bigger. We know a leg. We don't know the hypotenuse, so that's C. And we do know, okay, so we do know all of this is 24. So half of it is 12. And how did I know it's half of it? Because the distance right here from the center is going to cut that perpendicular. So these are bisected. Whenever you have the distance from the center to the chord, it's at the perpendicular distance, so it is the bisector as well. All right, so from there, we're going to do Pythagorean theorem again. This time we have both legs. We don't know the hypotenuse, that's the radius in this case. And We're going to have to do some factoring out on this one. So c squared equals 369. We'll need to do the square root of 369, but that is, when I did menu 2-3 in the calculator, it was, now I probably lost it. I think it was a 3, 3, and a 41. So this will come out as just a 3. You'll be left with the 41 is equal to c, but actually we're not calling it c, we're calling it the radius. So the radius is 3 square root 41 centimeters. All right, and the last example here is, given that the diameter of the circle QS, so this one's the diameter, and that QS is perpendicular to PR, QS is perpendicular to PR, so now you know that's bisected, those are bisected. What is the measure of arc PS? What is the measure of arc PS if the measure of QTR is 88? Okay. And T is the midpoint of QS. Oh, wow, there's a lot going on here. Okay, so let's go little by little. We know that QTR is 88. QTR, this is 88. We know that's a central angle, so therefore that arc will have the same amount. We already said because this was perpendicular, a diameter that is perpendicular to a chord bisects it. So that means these two lengths are equal, and so are the arcs, the corresponding arcs of those chords. So this is also 88. And we know that this measure makes 180. This whole amount makes 180. So if we've got 88 already found, we just need the rest of it to get us to the arc that they want. So we can just do 180 minus the 88, and that's going to get us 92. So the measure of QS, where are we? The measure of arc PS is 92 degrees.